One of the show-stopping cars here at SEMA 2022 is this Pistachio FD RX7 behind me with a custom Kaiser body kit and an amazing V12 in the engine bay. We're here with Adam from Smart EFI to find out a little bit more about the car. Now Adam, you've been involved with this car and the owner, specifically you've done the wiring, but you also know a little bit more about the engine swap, and from what I understand this is essentially the same engine that is in the Pagani Zonda. What specifically is it?
Yeah, so the Pagani Zonda had the M120 V12 AMG version. This is the M120 V12 out of like an S600, SL600 from the late 90s. We have developed this in-house and in collaboration with a local machine shop. But basically CNC ported cylinder heads, custom camshafts, custom valve train. It's got rods and pistons in it, head studs, head gaskets, all that. It's also got a custom dry sump that was actually designed in-house. The whole pan, all the bracketry for the dry sump was all designed in-house. Block-off plates for coolant, block-off plates for the variable cam timing. We blocked that out and went just straight camshafts.
Let's just stop and go back a little bit. There's a bunch of information that I want to unpack about that. So for a start, the two versions, or three there, you've mentioned the AMG version that Pagani used in the Zonda. Safe to assume that Pagani added their own special touches. Is that exactly the same as the AMG variant of the engine, or are there differences?
From what I understand, we talked to somebody who worked with the AMG project on the Zonda stuff, and from what I understood, it was essentially exactly what they did with some tuning changes.
And what sort of power was that producing in the Zonda?
720 was my understanding of what the Zonda made.
V12, how many litres?
6 liters.
Okay, that's a healthy output for a naturally aspirated 6-litre engine. Now let's come back to this base model from the Mercedes, the non-AMG version. What's that rated at off the showroom floor?
320?
That's a lot less. So obviously I'm guessing they're a little bit cheaper and easier to pick up as the base for a build.
Yeah, for sure. We've been buying up cars and spare motors wherever we can kind of get our hands on them. Those cars were fairly expensive and very expensive to maintain and repair. So as they've become older and kind of lost their touch, they've become easier to find and get our hands on.
Okay. Obviously, the V12 is a standout. It's hard to walk past this car without noticing it, particularly with the 12 individual throttle bodies that'll end up sticking out through where the hood will be. But were there any other elements that went into the selection of the engine for the car?
We actually did a project in the shop previously with the same engine on an S600 where we did a long tube header design for a customer. So we had to buy a motor to use as a mock-up to be able to build the headers. And Sam, the owner, was like, well, I've already got this engine here and it sounds wicked, so let's just stick it in the car and just see what happens. So
I mean, I think that's something that you can't get away from with these V10s and V12s, naturally aspirated, that are high revving. The sound is something that we'll never be able to get out of a turbocharged engine, and before I get flamed, I definitely am a lover of turbocharged engines, but there is something particularly special about the sound of a high revving, naturally aspirated V12. Now, in terms of the complexities of running an engine like this, obviously the engine management is a key element, and I know this is sort of your sole area of expertise here. So what was chosen in terms of engine management for the car?
So we went with the new Nexus R5 from Haltech. That ECU is particularly well suited in this application because it's got 12 injector outputs, actually got 18 injector outputs, but we're only using 12. It's got 12 ignition outputs, so it can run full sequential, direct fire ignition. It's got plenty of inputs and outputs for all the other controls in the car. It also is a PDM included within the ECU, so we're running headlights, taillights, fans, water pumps, all that stuff right through the same unit. So it's a very clean, simple installation, all in one, and replicatable. So
now, that's something that's really easy to overlook when you're speccing out an ECU. I mean, you pick an engine and think that the ECU selection's going to be not really a big concern, but When you do get up to V10s and V12s in particular, it does really narrow your options down because there aren't a lot of ECUs that actually provide 12 ignition and injector outputs. So that means that you can kind of make it run, but maybe you need to go to waste spark ignition and maybe batch fire injection. So some real advantages to be able to run this full sequential and direct fire ignition.
Exactly, yeah. So one, it's a V12. We're trying to make a lot of power with it. So coil charge times are obviously a concern. When you're doing wasted spark, you're discharging the coil twice as much, so it doesn't have as much time to sync the coil with energy. So being able to go full direct fire ignition gives us that full coil charge time. We don't, especially at high RPM where you're going to run into coil dwell issues, we don't have to worry about that.
In terms of that RPM, because you're right, it is a real issue with waste spark with the charge time available, but normally does become an issue, as you mentioned, right at the higher RPM ranges. So what are you expecting this built engine to rev to?
The intention is to rev it to about 9,000. We might try to push the envelope, but we're expecting that we'll run into valve float problems close to there. So
you mentioned the variable cam timing has been deleted. Is that an element that's been driven by the selection of the cam profile in it? And what I mean by this is the cam profile now big enough that really the continuously variable cam control would be so limited in its movement to be not that useful?
Yeah, one of the concerns, we weren't sure that it would even be able to move the cam with the aggressive profile that we went with. And then the other problem, it adds a level of complexity, another thing to fail, another thing to worry about when you're developing an engine with almost no support and almost no prior knowledge from other sources on what it's capable of doing, which obviously, like Pagani knows what it can do, but they're not going to come tell us what it can do. So we have to figure it out on our own. So simplifying that, cutting that out of the equation makes our development and our learning about what it's capable of a lot easier. And on top of that, it's a dedicated race car. So we don't need it to be efficient in many ranges. We can just pick a range. This is what we want to, spec the cam to, and then just build to that.
Now, helping with eliminating the need for variable cam timing is that this is now running a sequential 6-speed gearbox with tighter ratios, meaning that you're using a narrower rev range. What is the specifics of the gearbox you have chosen?
Yeah, so we went with an HGT sequential transmission. It's obviously also going to have a strain gauge, so no lift shifting, just grab gears, grab gears, grab gears. And so, yeah, like you said, we can specify what range we want the engine to run in and pick gears that are going to allow the car to be in that range pretty much all the time.
Let's talk about throttle actuation. Have you gone drive-by-wire with this engine?
No, we decided to go drive-by-cable, mostly for simplicity's sake. So they're Hayabusa throttle bodies, and they're just basically custom spacers. We made runners from the cylinder head up to the throttle bodies, and those are all custom. We had them cast. And then obviously all the spacers, all the linkages, all that's got to work together. To add drive-by-wire into the equation just adds a whole level of complexity that's extra difficult, and we want to be able to sell these to people, these kits, so you can buy one of these M120 V12s and buy the individual throttle kit and just bolt it on your car. When you add drive-by-wire in, you start to get into all kinds of other complexities that the average customer probably just doesn't want to deal with. Drive-by-cable, people can get behind that.
Drive-by-wire, relatively straightforward if you're running a plenum chamber with a single or even dual throttle bodies, but certainly adapting drive-by-wire up to an existing cable throttle actuated individual throttle body, while definitely not impossible, does add a layer of complexity with external remotely mounted motors. So I totally understand that. Coming back to the R5 just for a moment, you've mentioned PDM, power distribution module. This is quite unique about the R5 because, at least to the best of my knowledge, it's still the only ECU that includes both the ECU and the PDM in the same unit. Now, in terms of that, was the outputs from that power distribution module sufficient to run all of the electronics on the car, or did you need some additional outputs as well?
In this particular application, it is enough. Often, it's only a 16-channel PDM. So in a more complicated car than this is a pretty bare bones race car, you can run into issues with that. In this particular car, we didn't need to add any additional relays or anything like that, but in the other car that we have here, it's quite a bit more complex, and we ran 2 Kaizen relays in addition to the PD16, or sorry, in addition to the R5.
It's also worth mentioning that that's not an uncommon situation, particularly if you've got a road car which has a lot more going on than a race car, and piggybacking and adding additional PDMs is certainly not out of the equation. In terms of the wiring harness construction, that what you've made for this, what have you got here? Is this sort of a full sealed race spec style of harness?
Yeah, so this is a full motorsports harness. It's Raychem, concentric twisted, Tefzol wire. We use Milspec connectors in most of the applications and for bulkheads and stuff like that. We did one Autosport, but that was left over from the previous iteration of this car where we did the whole chassis harness before.
Let's just come back and talk about that. So you've used that term Milspec, and we'll show the 2 connectors that are on the bulkhead. And I mean, I think there's a lot of confusion around the term Milspec and then the Autosport connectors that really are the sort of the usual go-to at the top end of motorsport. Are similar, but some subtle differences. Can you explain the difference between the Milspec connectors you've used and the Autosport connectors?
Yeah, so the Autosports are made by TE. And obviously, they look very similar to the Milspec. They have a 2-hole flange versus the Milspec ones have a 4-hole flange. And also, the planforms are a little bit more available in the Milspec stuff than the Autosport. They're a bit more limited, at least as far as what you can get off the shelf. But other than that, they're very, very similar in construction and size and style. So
Cheaper price point.
Significantly cheaper, like probably 50% less for the Milspec stuff versus the Autosport, which is why we went that direction.
The other thing I will add in there is with a true Autosport connector, you're going to be limited to using Tefzol wire, which is the go-to if you're building a concentrically twisted harness anyway, so it's no big deal. But if you're using maybe something like TXL for your wiring, a slightly cheaper product, but the thickness of the insulation, there's absolutely no way you're going to get that through an Autosport connector. So that's where these Milspec connectors come in. There's a little bit more room to work with. They're designed for that thicker insulation around the conductors, correct?
Yeah, for sure. And also what I found is that it's much more conducive to larger gauge wires, the Milspec, whereas the Autosports are more designed for like 24, 26 gauge stuff. There's a lot more planforms that incorporate really small wire gauges, whereas the Milspec stuff is more designed around 20 gauge to 16 gauge.
That's a good topic to just talk about for a moment there, because obviously the gauge of wire we need to choose is very much driven by the current handling requirements for that wire. So, if we're using a Milspec bulkhead connector that's maybe all set up for 20 gauge wire, 20 gauge might handle maybe around 7, maybe 8 amps. And if you want to handle more current, maybe you're wiring through that bulkhead connector for the likes of a thermo fan, which could pull 15 amps. How can we go about that if we're limited to a 20 gauge contact?
Yeah, so we do actually, in this particular case, we do branching. So for like the coil power wires, right? The planform that I used has 8 16 gauge wires. So we weren't limited in what we were using for pass-through power, because I just ran basically a 12 gauge from the ECU's 25 amp output up to the bulkhead connector, and then I did a splice to two 16 gauge wires per output. And then on the other side, I took those 2 16 gauges and I split those to 3 20 gauges each to run out to the coils.
Yeah, so I think it's important for people to understand that we can do some little tricks here with the branching either before or after these connectors to get a little bit more flexibility and a little bit more current handling capability. Of course, if we do need to split a wire into 2 to get the current handling capability, we're then using up 2 positions in the connector, so that's also worth thinking about. Now, in terms of sealing the wiring harness, this is one of the elements of a professional motorsport racing style of harnesses that they're generally sealed using products like DR25 and heat molded boots. This gets a little bit tricky when we're dealing with some OE level connectors because there's not always an easy way of booting a connector. How have you got on there? Was everything sort of okay to boot? Did you need to do any modifications, or is there anything where you've actually had to pot a sensor or an actuator and run it to a Autosport connector or the like?
Yeah, there's definitely challenges. In this application particularly, I haven't yet found a crank sensor connector. So that's one thing that we are looking at possibly potting and just running to a DT2 or DTM2 rather. But then as far as like modifying connectors for boots, we have K-series coils on this car. And those connectors, they don't have a lip for a boot. So I ended up actually modifying the connector bodies to be able to make them bootable. And then we used obviously Raychem shrink molded boots and RT125 to seal that all up and make it look nice.
So the idea there is ultimately when it's finished, there's absolutely no chance of dirt, dust or moisture ingress into the harness, adding to the reliability?
Yeah, for sure. And then obviously strain relief between not only the loops that we put inside the boot, but then also the boot and the Raychem itself is providing strain relief as well.
It's important, yeah, that's easy to overlook as well, the importance of managing that strain relief. So essentially if any force is placed into the harness, maybe someone's trying to remove it and they're a little bit ham-fisted with that, and we want to make sure that any force put into the harness doesn't make its way into the back of the contacts, correct?
Right, yeah, because those little tangs on the pins are very, very small and they're quite easy to damage and bend, and then you don't get a good seat. You'll end up having intermittent problems or really difficult things to chase down electrically. So we're trying to avoid that at any cost.
All right, Adam, look, it's been great to get some background on the vehicle. It sounds like you're gearing up to actually offer these engines as a package. So if people do want to find out more about that, where are they best to do so?
Yeah, so those engine packages will be supplied through Gooichi Motors. You can find them on Instagram at Gooichi Motors, Gooichi. And yeah, they're basically building right now, I think 6 of these packages. They have a cylinder head package available, or you can get a whole long block. You can get just the throttle bodies and fuel rail setup, kind of whatever you need. Just reach out to those guys and let them know what you're looking for, and they can get you set up.
And if people want to reach out and maybe utilize your wiring skills, how are they best to do that?
Yeah, so the best way is either through my Instagram at smart_EFI or email me adam@smartefi.com.
Perfect, and we'll put some links to those in the description as well to make it super easy for people to find. Look, thanks again for your time, Adam. Really appreciate it, and enjoy the rest of the show.
Awesome, thanks. Appreciate it.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.